Hello viewers, welcome back to my channel Stepping Stone Tutorials. Dear viewers, this is my new video in continuation of my earlier videos on the chapter Electricity of Class 10 Science. Dear viewers, in my last video we discussed about Ohm's law and then in detail about resistances. Now in this video we will see how two or more resistances can be combined in series or in parallel, and then we will try to find out the equivalent resistances in both the cases. When two or more resistances are connected end to end consecutively, they are said to be connected in series. First, let us try to find out the resultant resistance of two resistances connected in series. Okay, so in here you can see two resistances R1 and R2. They are connected in series or lengthwise. So we will try to find out the resultant resistance R of the two resistances R1 and R2. So hope you understand, we have to find the equivalent resistance in this circuit. Now you can see from this diagram that the potential difference applied V is equal to the potential difference V1 plus V2, right? Now by from Ohm's law we know that R is equal to V by I, where R is the total resistance or equivalent resistance of this circuit. So R is equal to V by I, so we can say that V is equal to IR. Similarly, by applying Ohm's law to this resistance R1, we can write that V1 is equal to IR1. Similarly, we can get V2 is equal to IR2. Now, putting the value of V, V1 and V2 in this equation, equation 1, we get IR is equal to IR1 plus IR2. So next IR is equal to, here in the right hand side we will take I common, R1 plus R2. So we can cancel out I from both sides. Then finally what we get is R is equal to R1 plus R2, which is the required relation for resultant resistance. So we can say that resultant resistance in case of series combination of resistance is equal to sum of all the resistances. Now we will try to derive a formula for calculating the combined resistance or equivalent resistance of two resistors connected in parallel. So here you can see two resistances R1 and R2 connected in parallel. Now in this case the potential difference across the two resistances R1 and R2 is the same as the total potential difference applied across the ends. That is, here V1 which is equal to V2 is equal to V. The same potential difference is applied across R1 and R2 also. But current here does not remain the same. You can see that the current I divides into I1 and I2. So I1 is the current flowing through the resistor R1 and I2 is the current flowing through the resistor R2. Now, so the total current I is equal to I1 plus I2. Now from Ohm's law we know that R is equal to V by I, or we can write I is equal to V by R. Similarly we can V by R. Similarly we can say that I1 is equal to V by R1 and I2 is equal to V by R2. Now, putting these values of I, I1 and I2 in equation 1, we can write V by, instead of I we will write V by R is equal to I1. In place of I1 we will write V by R1 plus, in case of I2 we will write V by R2, or V by R is equal to V common 1 by R1 plus 1 by R2. So both sides you have V, we can cancel out V. So finally what we get is 1 by R is equal to 1 by R1 plus 1 by R2. So this is the required relation for resistances connected in parallel. Now since we have learned about combination of resistances, we will try to solve a problem. Find the equivalent resistance and current I in the circuit given below. So here are three resistances of 10 ohm, 20 ohm and 30 ohm. We need to find the current in the circuit. Since all the resistances are connected in series, we will first find out the equivalent resistance R. Now in a series connection, the equivalent resistance is sum of all the resistances. So R is equal to R1 plus R2 plus R3, that is 10 plus 20 plus 30. So equivalent resistance is 60 ohm. Now the potential difference is 12 volt. Now according to Ohm's law, R is equal to V by I. So now we will put the values of R and V. R is 60 and V is 12. So now I is equal to 12 by 60. One by 5 or 0.2 ampere. So current in the circuit is 0.2 ampere. Now we will try to solve another problem where the resistances are connected in parallel. Find the equivalent resistance and current I in the circuit when potential difference V is 6 volts, resistance R1 is 3 ohms and resistance R2 is 6 ohms. Here in this problem you have to find out the equivalent resistance R and the current I in the circuit. Now for parallel connection, we know that the equivalent resistance is given by 1 by R is equal to 1 by R1 plus 1 by R2. Now here R1 is 3 and R2 is 6. So the value will come 3 by 6, which means half. So 1 by R is equal to 1 by 2. Therefore, R is equal to 2 ohms. So equivalent resistance in this circuit is 2 ohm. Now to find out the current, we have to apply Ohm's law. From Ohm's law we have R is equal to V by I. Now just put the values of R and V. R is 2, V is 6. Then we need to calculate I. So I will be 6 by 2, which is equal to 3. So current is 3 ampere. Now electric power. In mechanics we have learned that power is nothing but work done by time taken. So electric power is also electric work done by time taken. The SI unit of power is watt, represented by capital letter W. Actually, watt is a small unit. Therefore, a bigger unit of electric power called kilowatt is used for commercial purposes. So it is obvious that 1 kilowatt is equal to 1000 watt. How do you calculate power? The formula is P is equal to V into I. Power is equal to potential difference into current. Another formula you will use in solving several problems is P is equal to I square R, where R is the resistance. The commercial unit of electric energy is kilowatt hour. So this is the unit that is actually used commercially. When you will get your electricity bill of your home or office, you'll get the unit as kilowatt hour. Next topic is heating effect of current. You might have noticed that most of the appliances where electricity is passed, they become a little warm or hot due to the passage of current. Why this happens? Because some of the electric energy gets converted into heat energy. For example, when electric current is passed through a fan, the most of the electric energy is used up in running the fan. But a small amount of electric energy is converted into heat energy by the fan. Due to this, an electric fan becomes slightly warm when they run for continuously for a long time. This is nothing but the heating effect of current. So when an electric current is passed through a high resistance wire like nichrome wire, it becomes very hot and produces heat. This is called the heating effect of current. Now, why this effect comes into play? This effect is due to the transformation of electric energy into heat energy, and this effect is used in electrical appliances where heat is required. Okay, for example, when electric current is passed through an electrical heating appliance such as electric heater or electric kettle, the most of the electrical energy is converted into heat. So this effect finds its application in electrical heating appliances. How do you calculate heat produced? H is equal to I square R